Hi, this is the third and final video for Math 1105 Rational Functions. We talked about vertical asymptotes in the first video, horizontal asymptotes in the second video, and in this third video we'll talk about what are called oblique asymptotes. Now this is a new kind of asymptote for us, but it's not really a new process for us. We have done what we have to do to get an oblique asymptote. So first let's talk about when we have an oblique asymptote. So what we saw was that if the degree of the numerator is greater than the degree of the denominator, we have no horizontal asymptote. That is still absolutely true and is always true. However, if you have a very specific circumstance where the numerator degree is just one bigger than the denominator degree. If it's just bigger but only by one, we still do not have a horizontal asymptote, but we have what's called an oblique asymptote. Now, I think it differs what maybe book you're looking at or who your teacher is. These are also called slant asymptotes because instead of just being a horizontal or a vertical line, these are actually slant lines or oblique lines, whichever way. But these are still asymptotes. These are still where the graph will tend as x goes to infinity. So let's talk about how to find them because we already know the process. We just didn't know they were called oblique asymptotes yet. So the way that we find oblique asymptotes is we do division, and we already know how to do that. We're going to use synthetic division for these. And the quotient polynomial is the oblique asymptote. All right, so when we talked about, remember whenever we did synthetic division, we always took the denominator down by 1. So these are all going to end up being linear polynomials in the end. So you should end up with something that looks like a linear function whenever you find your quotient. All right, so let's do a couple of examples finding oblique asymptotes. So our first function we'll look at is x squared plus 3 over x plus 3. Okay, now we're not going to be tempted to reduce this, first of all because we don't have to when we're looking at oblique asymptotes, but also because this doesn't reduce. Just because they both contain an x and they both contain a 3, let me fix the camera a little bit so there's not such a glare. Not gonna work. All right, there we go. They both have an x and they both have a 3. That doesn't mean that this will reduce at all. Remember, something can only reduce out if it can be factored out. And none of these can be factored at all. So this doesn't reduce. We don't really care about that for oblique asymptotes, but just to let you know, it does not reduce. Okay, so we're finding an oblique asymptote. What we want to do is division. So we're going to treat this like a division problem from the last section. Okay. Whatever's in the divisor, the opposite of that number goes in the box, and then we list off the coefficients of the dividend off to the right. Again though, we notice that there is no x term in here, but we have to have a place for it. So don't forget to put that in if it's missing. So our coefficients are 1, 0, and 3. Skip a line, draw your horizontal line, and the first number comes down. Okay, so we multiply by the number in the box to get -3, add to get -3. We know this last number is the remainder, and we don't care about the remainder here, so you're welcome to just stop if you want to, but just to complete the problem. -3 times -3 is 9, 3 plus 9 is 12, and we have a glare problem. There we go. It's still bad up here. All right, so our remainder is 12, not really something we care about at this point. We care about the quotient. So the quotient here is given by 1x minus 3. And we put a y next to it. You can call it q of x if you want to, but we want this to look like a linear function or a linear equation because these are lines. So we write it as y equals 1x minus 3, just using the quotient from whenever we do division. And that's our oblique asymptote. All right, let's look at another one. Same idea, we want to find the oblique asymptote. Oh, we didn't even talk about how we knew that one had an oblique asymptote. It was because the degree of the numerator was 2, the degree of the denominator was 1, so they just had a difference of 1. All right, let's look at this one, and we'll remember that step in this problem. X squared plus 3x minus 5 over x minus 1. Okay, so first of all, let's talk about how we know there is an oblique asymptote here. We know there is one because the degree up here is 2 and the degree down here is 1. So like we talked about before, there is no horizontal asymptote here. But because this one is exactly 1 bigger than this one, there is an oblique asymptote. So let's find it. We're going to use division just like normal. Opposite of what's in the divisor goes in the little box. The coefficients, which thankfully this time we aren't missing any, go off to the side. Draw a line, bring down your first number, and we're ready to go. So let's do our synthetic division to find our quotient. So multiply by the number in the box to get 1, add to get 4. Again, you can stop here because we're only interested in the quotient, but go ahead and figure out the remainder if you want to. The remainder is -1. So our quotient here has these two coefficients on it, and it's going to have 1 degree less than the numerator. So we have y equals 1x plus 4, or y equals x plus 4. And we know that's a linear equation, and these should all look like lines, or linear equations whenever you're done. All right, so those are oblique asymptotes. The only case we haven't talked about yet is if the degree of the numerator is bigger than the degree of the denominator, but is more than 1 bigger. So we don't get that kind of second chance to have an oblique asymptote. So let's look at an example like that. X cubed minus 3x squared plus 2x over x minus 7. All right, so we know right away this thing has no horizontal asymptotes because the degree up here is bigger than the degree down here. So no horizontal asymptotes. We'll just go ahead and write that down. None. But we have that second chance. If the degree of the numerator is just 1 bigger than the degree of the denominator, we could have a slant asymptote, an oblique asymptote. But the degree up here is 3 and the degree down here is 1. So they differ too much to be able to have an oblique asymptote. So there are no oblique asymptotes either. And that's the answer. No horizontal asymptotes, no oblique asymptotes. If we were looking for vertical asymptotes, that might be a different story, but we're not, so we don't have to worry about it. And so that concludes the section on rational functions.